So I'm going to kick off, and towards the end, I'm going to hand the talk over to Harrison. We want to talk, well, morning your time, we want to talk about spatial data science. Let's see whether I can get it to go down. Okay, so to tell you what we're going to do then, I'm going to talk about spatial sciences as a field of study and a body of knowledge and skills around which one can already build a career. And I'll show you some examples of what those careers look like. And then I'm going to talk about the same length of time about the emergence and use of spatial data science to produce and share valuable and excellent information. And then I'm just going to take a couple of minutes to show you our spatial data science curriculum. And then Harrison's going to talk about his experience as a student. So the spatial sciences then is a field of study and body of knowledge and skills around which one can build a career. So the spatial sciences combine typically they combine multidisciplinary fields of scientific study with geospatial technologies, and those technologies traditionally have included geographic information systems, or GIS, global positioning systems, GPS and remote sensing. And in this diagram here, on the bottom left, there's a picture of a whole bunch of satellites orbiting the Earth that are the basis of the positioning system that's used now all around the world. The United States has a constellation of satellites in the sky. China does, the European Union does, Russia does, and in most cases, there's now on the ground GPS equipment that can access any and all of those satellites in order to achieve high precision positioning. The picture on the right at the bottom is one that describes sort of GIS. And the very first thing I want to share with you then is that many people think of GIS as a system of hardware and software, but it's more than that, because there's a series of procedures. In order to use it, you need geographic or geospatial data. And most important of all, you need people, and all of those things have to interact and work together in order to produce useful products. And then a snippet of why we want to migrate then from the spatial sciences perhaps to spatial data science is, of course, as the magazine cover at the top shows, we suddenly find ourselves smack bang in the middle of a world in which we have ever larger amounts of data. So what should a spatial graduate be able to do? Well, as you might expect, they should possess an advanced knowledge of these technologies, GIS, GPS, and remote sensing. Therefore, they should have experience in the interpretation and processing of satellite images as well as other digital data streams, a broad understanding of computer applications and database management. That's necessary but not sufficient, because I think they also need to know the spatial principles and methods used to characterize the role of location and the functioning of the Earth and everything we do. The two pictures here in the middle of my slide are purposeful. The one on the left is simply to remind us all that we can do spatial science without using a computer at all. Here's somebody with coloured pens that's making a planning map for maybe a new subdivision or an adjunct to an existing city. And so the spatial principles and methods actually existed long before computers came on the scene. And the picture on the right is a picture of a Nobel laureate, Kazuo Ishiguro. He won the 2017 Nobel Prize in Literature for a book he wrote. And I just want to remind you that he won the prize because of the ideas contained in his book. Microsoft, who produce word processing software, Microsoft Word, have never won a Nobel Prize. And so the tools are necessary but not sufficient. One thing that's really handy about the present day is that we have a very rich sort of geospatial domain. In this slide, I've got 3 different things going on at once. So on the top sort of right and in the middle, I have all kinds of different software, some of which might be familiar to you. One in particular is a Chinese product, Supermap. Some are originated as GIS, some only deal with spatial analysis, some have many, many functions like Tableau, and some of the functions they have work with geospatial data. Along the bottom, I have a series of organizations that provide professional services, professional training, in some cases, various kinds of certifications. It includes the Open Geospatial Consortium, which is an organization dedicated to promoting interoperability with all of these different kinds of database and software products. And then down the side, I've got examples of 3 professional organizations. The top one, the University Consortium for Geographic Information Science, the US organization. It's largely founded by geographers and other people interested in maps and things like that. The one in the middle, the ACM Spatial specialty group, is mainly computer scientists, and they're interested in the technical aspects of GIS. And the one at the bottom is the International Association of Geographic Information Science. And I think I'm one of 2 scholars that were lucky enough to win a Lifetime Achievement Award from this particular organization. And they specialize in connecting geographic information scientists in China and throughout the rest of the world. So spatial then is special. And one of the reasons it's special is because they're used to paint an accurate picture of the gross national productivity in China, gross domestic productivity rather. And the one on the, so that's a big picture, so that's approximating the global. The one on the bottom right is Barcelona's car-free superblocks that many people think could save hundreds of lives because they're going to reduce air pollution emissions in large, dense urban areas. And the important thing here is that to do creative work here, I think a person needs a blend of science, engineering, and design. Maybe you don't need them in equal amounts, but when I was introduced and you saw I have all these different roles on campus, I've sought them on purpose because in order to make an impact, I need to know something about science, something about engineering, and something about design. So now let me go to Esri, very large software company. It's present in every corner of the planet. And I want to use this slide not to promote their software so much as to show you what the power of GIS is. And so on this diagram, there's a number of things we see that are important. Well, it talks in the middle there about a web GIS. And so we can support now multiple types of systems. There are multiple ways that users can access and use those systems. You can think of working with a map and making new maps. You could use some kind of visual programming language. In Esri, they call it Python, and write your own code. That might be notebooks. And they've got runtime SDKs and a variety of other ways to connect with the software and the data that the software connects to. The idea is that you're going to produce new and actionable information. There's an underlying geospatial infrastructure that I'll talk about in a second, but there are really 3 systems in one here, and that's the beauty. This GIS is a system of record, knowing things where things are and when they are there. The GIS is a system of insight, and for that you'd normally have data and apply analytics so that you could learn something new. And there's also this role of GIS as a system of engagement to promote planning, collective action, all kinds of different things. And the power comes from not one of these things, but all 3. And you know, one of the great pities in the world right now is that in many universities, colleagues like me focus just on the analytics. They ignore the system of record and the system of engagement. And I would bet all around the world, no matter what product we're talking about, that a lot of GIS of record. So let's go on. So those 3 here, system of record, the system of insight, and then the system of engagement. One way to illustrate the system of record is to look at geospatial infrastructures. So the one on the right here is for the Arctic, and for the Arctic Ocean and the islands and land masses that surround that. So parts of Scandinavia, parts of Canada, parts of Russia. So it's the very top of the earth. And the spatial data infrastructure can be used to support scientific investigations. It can be used to support governance and security. It can be used to support navigation and logistics. It can be used to support emergency and disaster management, commerce, resource management, public health, and even education. And so you already begin to see that there's a world of possibilities if you were trained in this session, where you might find a good niche for you in terms of a career and a job and an income, things like that. People have conferences now where the focus is on geospatial infrastructure and how to make it better. The Esri Federal GIS Conference was an example back in 2019. And here's a presentation by Carl Grosner, the World History Center at the University of Pittsburgh, where he's linking past with historical gazetteers. And my colleague Peter Boll at Harvard University has done some groundbreaking work of this kind in China, and is now part of the Harvard world. Means that you want to apply statistical and other kinds of analytical techniques to make sense of the data and therefore the world. And there are many things about spatial that are special. There are some things that I've provided my whole life is that you can use something called geographically weighted regression to make sense of geographic data. You can use thin plate splines, or you can use a whole family of just statistical techniques called kriging. Most people in proposition then and why you can use the spatial sciences to find new discoveries and new actionable information if trained like me. And then have a slide that shows you the nuts. This is Kong Jiang Yu, principal designer and founder, I think, of a design firm in Beijing called Dornsife. He's also a professor in the College of Architecture and Landscape Architecture at Peking University. And here somebody's put together a series of articles about both Kong Jiang Yu and his work, designed ecologies, the landscape architecture of Kong Jiang Yu. And I'm very familiar with his work. I've met him many times. I'm always inspired, and GIS and GPS and so forth in nearly all of his designs. And so this is a system of engagement, how to engage the people of the place, how to engage the government, how to engage people so that they can connect with your designs and make sense of the world and whether or not they want to do what you propose. Super hero of mine. So let's turn to the professions. So here's a company. I have no relationship with this company whatsoever. They go by the name GHD. They're a global professional services company that leads through engineering, construction, and architectural expertise. They think they're forward-looking. They have innovative approaches that connect and sustain communities around the world. They deliver extraordinary social and economic outcomes, and they are focused on building lasting relationships with their partners and their clients. The company was founded in 1928. It's a wholly owned company by the people that work in it. There's more than 10,000 diverse and skilled individuals connected by over 200 offices across 5 continents. So this is a company that's working in Asia, that's based in Asia, working in Australia, based in Australia, same in Europe, same in North America and South America and the Pacific region. So they, as far as I can tell, are everywhere but for the continent of Africa. And they work they give advice. They work in energy and resources, geosciences, transportation, water, environment. These were all things that were on that Arctic spatial data infrastructure diagram I showed you. And they promote themselves as a company with innovation and technical expertise, ideas at their core. And when you look further down, you know, they have a group that specializes in spatial sciences consultation, surveying, GIS, and 3D modeling. And I've just highlighted in red here where they make connections to the spatial sciences. So on the left, high quality geographic information and data. Below that, location data. And then on the right, drawing new insights and supporting decision making via spatial analytics and advanced image analysis, facilitating easy access to complex information via web information tools and high quality cartography. Setting up projects for chess with considered spatial strategy. They do everything that a person would do with a degree in spatial sciences or in the future, spatial data science. So let's turn then to the spatial data science piece and how this can produce and extend our ability to produce valuable and actionable information. So what's changed about the world is, of course, this data deluge, the big data era that many people now we live in. It's been around for a while. The Economist magazine cover here comes from 2010, and somebody was writing then about the data deluge and how to handle it. And this particular copy of the magazine includes a 40-page special report, and it talks about the volume of the data, the velocity, the speed with which the data is acquired, the variety of data, comes in all sort of shapes and sizes, the veracity, whether it's any good or not, and then its value, right? And so these are big questions, but we've seen in the last decade that there's many very important and powerful applications that you can use these. All of a sudden, in the satellites, sometimes referred to as CubeSats. So we have more data, the launch costs are cheaper, the sensors are getting smaller and smaller and smaller, and the data are continuously downloaded to commercial downlink stations. So more data comes faster. The analysis can be done faster too, because we have cheaper processing power and artificial intelligence that enables faster analysis of not the data that we've now put in storage, but the data as it's streamed from the satellite back to Earth, right? And so we're looking at finding value in data almost instantaneously. And as a consequence, then we're looking to produce operational products, near real-time imagery and AI-detected items of interest. Every country in the world is probably doing this, as well as every business in the world. And the whole idea here is to go from data to decisions. We have going to be a sensor. So as a sensor, using your cell phone, typically you're anonymous, even though it's your personal electronic device. And on your phone, you have location-enabled apps. There's billions of rows of raw spatial temporal data that can be generated just by you walking around with your phone. There are many commercial vendors now that produce phones and, of course, are busy aggregating data from people's phones anonymously. The characteristics, we have data sets in the United States now that cover 25% or more of the US with a phone that participates. There's 100 or more smart hits per day at a resolution of about 30 meters, and there's a possibility of offline operation. So another new and important and quick and big data set that we could use to understand various facets of human behavior, both in a crisis like COVID, but also in ordinary times, as we work to refine our ability to bring products to market and find customers for those products. And so the typical spatial data works follows this kind of path here. So first you have to get all these different data streams, conduct some kind of exploratory data analysis. The purpose here might be to decide which kinds of machine learning or both the data and the problem at hand. And then you might try to model the observed data and then perhaps model the relationships and make predictions. And then when you get to the end of that workflow, you want to make decisions. Now, the beautiful thing here is this workflow and the kinds of data we're talking about can be used to improve the efficiency, just exactly like the one on the top left. That's the gold line that takes you from downtown Los Angeles to Pasadena. It could be that you could use these kinds of workflows to optimize the performance and therefore the management of an oil pipeline, like in the bottom. Many people in the world that are undernourished. We could look for ways to use this workflow to improve the efficacy of our production food production systems in every communities, and people trained in spatial data science have an opportunity to participate and make a difference in the world. By ongoing relationships and the Institute for Geographical Sciences and Natural Resources Research. So here's some work that uses big data, uses data science, but also has a journal, Science China, and actually on the front cover, because among other things, our work is using satellite imagery to advance surface system modeling for eco-environmental surface management. Many colleagues, I'm just one of a big team of scientists here, and we're using some statistical techniques that require cloud computing, heavy computation, lots of data, called HASM, which is high accuracy surface. We're focusing on Beijing, Tianjin, and Hebei region in north central China, be known to most of you. Upscaling of the elevation surface, the spatial downscaling of the global climate models. The third was data fusion of atmospheric temperature. The fourth was spatial interpolation of mean annual precipitation. And the fifth was model data assimilation of carbon. So looking at carbon sequestration, we're using data from the fifth phase of the coupled model intercompare models of what's happening to the atmosphere, and using GPS-based data from a Chinese data collection system. And in this particular map, we're showing elevation, so the blue area is higher above sea level. So here's the meteorological stations that covered the study area that we chose. There's only about 328. So from a satellite, we have gobs of data, but from observation stations, we have relatively little data. And here's the only result I want to show you. So at the top left, this is what the climate model told us about mean annual temperature in this part of China. If you use ordinary least squared regression, so it would be before where we've got these advanced techniques with multiple data streams in play, and this was the mean annual temperature for the period 1976 to 2005. In other work, we've now gone and where we're heading then is spatial computing anywhere, anytime. We have smart apps that we can put on a person's phone that can generate new kinds of data. So this thing called an ecological momentary assessment is where an app on your phone would prompt you for answers to a question. Maybe you're a parent and you have a child that suffers from asthma, and so we want to learn when the young child, young girl or boy, has an asthma attack. When does wheezing start? Where are they when it starts? Because if we could know that information, then to avoid those kinds of situations and the terrible outcomes that causes. But the idea of the Internet of Things and sensing is huge, and even though it's in its early days, it's going to transform the world, and spatial data science is a key piece of that. So to our programs, how do we plan to prepare students for careers as spatial here? So we currently technology, another in human security and geospatial intelligence. The one in red there is the program Harrison is in now, and he may talk about. And the one at the bottom is an MS in spatial economics and data analysis. And there's no best program one of these programs is not best for everybody. There are different people for whom each of these programs would be the best choice. And it depends on your background, previous training. It depends on your interests, and frankly, it depends on your aspirations. But in every case, these degrees are trying to connect people with the economy and with the environment, because the future and future innovation depends on us being able to connect people with both the economy and the environment. And so if I just focus on spatial data science, it's a 2-year program, so there's 4 semesters. Half the classes come from the Department of Computer Science, the other half come from the Spatial Sciences Institute. We cover data analysis, data management, data mining, data visualization. There's the possibility necessarily entail in cloud computing, big data, data science, open science, replicability and reproducibility. These are data science and other flavors of data science. So with that, it's my great pleasure to hand the floor to Harrison Knapp to talk about the student perspective.
Hello there. Can you all hear me?
Yep.
Yeah, awesome. Wonderful. Well, as Dr. Wilson mentioned, my name is Harrison, it's master's program. And I'd love why I personally went to, or selected rather, the spatial data science master's, what I'm getting out of it right now and most enjoying, and then also how it is setting me up for success and how it can set you up for success as well. So next slide, please. So when thinking a little bit about, I guess, how to sum up my interests and kind of my approach to learning and applying skills, I came up with this little sentence, which is just, I think of myself as someone who's passionate about leveraging remote sensing and geospatial analytics to solve the world's problems. And so I guess to decode that, Dr. Wilson already explained both of these concepts pretty extensively, but remote sensing is the idea that we can take information about one place from another place. So if you're standing across the street and you see a building you find interesting, take a photo of it, that's technically remote sensing, because although you're not maybe at the foot of that building, you're gaining information from it. And so when we think about remote sensing in the context of spatial sciences, spatial data science, et cetera, frequently we see that take form in satellite data and kind of using different satellite platforms to get information about the Earth. And that can be anything from optical imagery, right? So just pictures, to special sensors that can detect things like surface temperature of the Earth, salinity, radar systems that give us information, kind of instrument systems. And so I came into this, I guess, love for this technology and applying it in environmental science context through my undergrad experience, and then also kind of the various internships that I've held since then. So undergrad at USC, I've been with Susan and John for a while. Very thankful for that. And I had 2 undergraduate majors. And so the geodesign program, just to sum it up at USC, is kind of focuses on applying GIS and planning and development, right? We better understand the human environment, the built environment, and how do we apply geospatial analytics to better improve our designs, for people. And then kind of on the other hand, I chose to invest in the earth science degree because I also wanted that kind of foundational natural science education in oceanography, climate science, geology, to understand the natural environment too. And so my interest kind of lies at the intersection of those 2 things, and using all of these technologies that Dr. Wilson explained to kind of understand how we as people interact with the world around us. And so that interest has, I guess, bloomed, and my skills have been further, I guess, built by the internships that I've held and the jobs and kind of the wonderful mentors that I've met along the way. And the most foundational of those were my 2 internships at NASA in the Jet Propulsion Laboratory, which is an organization here in Southern California, and then NOAA, which is an organization in the United States that focuses on weather and climate and oceanography and that sort of stuff. And so my projects in those two, at those two organizations focused on things from looking at ocean data and trying to figure out how different oceanographic factors were affecting this fish population that was at risk. And I also helped build a machine learning model that helped classify forest cover in the Amazon to better help forestry representatives. And I had a litany of different projects that I was working on, but I guess the common thread through those was this idea of geospatial technologies and how interesting the applying those methodologies is to different problems. And so next slide. That kind of led me, after graduating undergrad, to think, okay, what do I want to do now that I'm moving forward with my life? How do I want to continue to grow and continue to learn new things and better myself as an analyst, as a data scientist, et cetera? And for me, the answer was very easy. It was the spatial data science program. I very much wanted to do a master's. I didn't necessarily want to commit to a PhD, but I still wanted, before entering the workplace or entering some sort of career moving forward, to gain a more robust technical background and also theoretical understanding of the different statistical analysis techniques I had been using and the geography that informs them. And so spatial data science was kind of the right all the different technologies that I'm learning about now and I'm excited to keep learning about. And so just to gloss over all of them, I've been learning about using Python in scientific programming, scientific computing spaces. I've learned a whole lot about machine learning, thanks to our colleagues at Viterbi. Stuff with GI science and Esri technology and remote sensing. And then also everything you see on that kind of top half there, which focuses, I think, a little bit more on the data mining and database management side. So understanding cloud computing, Amazon Web Services, parallel processing, just technical and nitty-gritty aspects of what it means to be a good data scientist. And for me, I'm just really excited about this opportunity to continue growing my general understanding and my technical abilities in geography, and then also supplementing it with the very attractive programming abilities and kind of other data sciencey skills. So next slide. I kind of just went all over this already, but there's me, and there's kind of why I'm in spatial data science. I'm looking to develop a stronger technical background, better understand theoretical concepts of statistical analysis, geography, all that good stuff. Learn how to better apply my knowledge in practical senses, right? I think USC and our department in particular does a really good job of pushing us to take the learning and the theory and the skills and then actually put them towards projects, right? And so you have deliverables that aren't just, oh, I know the algorithms, or I know kind of the anatomy of the case, and then also how do we work with other people, right? Because that's incredibly important for all jobs and stuff like that. So those, I guess, ideas have better set me up for success moving forward to get a career in some of the things I mentioned already. Remote sensing. So I guess, working for any number of companies like Planet or others that are launching satellites and looking at the imagery to do interesting things and assist various, work domains or geospatial data engineering, right? So fortunately, I guess, for us geographers and for you all, should you join this program, like Dr. Wilson mentioned, everything happens everywhere. So data always has a geographical component, and your skills, not only as a data engineer, but also as someone who understands geographical data, is really attractive. And so, for me, I'll be applying, I guess, to positions at places like Google Maps or Apple Maps and kind of any platform in tech that looks to build out their geospatial platform. But fortunately, if those things and the stuff that I'm interested in doesn't reflect you, this program is really incredible for being not only adaptable, but has a wide, I guess, swath of people and ideas. And a lot of my colleagues and fellow students come from totally different backgrounds and have different interests. And so my student doesn't look just like me, it looks like you. And that can be anyone from you could be interested, like I mentioned, in data engineering roles, right? So helping a company build out their ability to ingest and process and analyze data and then serve it to customers, right? And that's more the development operations, the DevOps side of things, and kind of solving how do we optimize algorithms? How do we make sure this platform runs to the highest of its ability? But then you also have data science people, and those are the folks that maybe are looking at the data in a more exploratory sense and looking to have their data. And like I just mentioned, everyone has data. Data is created all over the place. And so regardless of your interest, whether it's in finance or commerce, or there's a scope for you. And fortunately, it's not just the data aspect that's valuable, it's also your understanding of geography and the fact that things happen in space and time. And then also, past, I guess, the more data science-y roles, there's also the stuff on the geography side that's incredibly interesting as well, whether that's GIS technicians, cartographers, people who are helping build out, an organization's ability to, I guess, solve problems that have geography components, which is a vague way to put it, but you could be helping natural hazard management groups help firefighters get to the right place at the right time, right? You could be a remote sensing specialist, like I mentioned, looking at hyperspectral imagery and identifying where chemical leaks in a pipeline are. And so these are just, some examples of the possible career paths. But I just mentioned all of this to kind of illustrate that our program and our department is really for everyone. And you can certainly find a place here to develop the skills that you're interested in and build forward, finding a job and, success academically moving forward. So next slide. That's it for me, but I know that Dr. Wilson and I are excited to field your questions and
Thank you, Harrison.
All that good stuff.
So I couldn't have said it better myself. So we'll stop there and we can take questions.
Thank you so much, Professor Wilson and Harrison, for giving such an excellent presentation and valuable information. I noticed that first one will be it's from Carol. Originally, I wanted to apply data science, and now I think spatial data science sounds more interesting. Should I apply for both?
So maybe I can take that question. So one thing about graduate programs in the United States, including USC, is that you want to make that decision about which program is best for you upon application, because unlike, say, an undergraduate student at USC who can change majors, graduate students typically can't just put their hand up and change majors. So my advice is that you want to ask your heart of hearts and your head of heads, and then to make an application to that program. If in fact, one's 5% better than the other, there's no guarantee that if you get into one program, you'll get into the other strategy as well. When I grew up in New Zealand and I wanted to do a PhD somewhere else in the world. And so I, in the end, only applied to two schools, the University of Hawaii and the University of Toronto in Canada. I was fortunate enough to get in both. Probably when I applied, Hawaii seemed a lot more attractive, but after I got both offers and I thought about it, New Zealand's a tiny little island of the Pacific, so is Hawaii, and I thought, wouldn't it be exciting in life to? That was a really good decision on my part. I think it was the right decision. But when I was applying, I didn't actually know that there was more opportunity if I went to the University of Toronto than to the University of Hawaii.
Thank you so much.
Sorry, just to add one short anecdote to that as well. I think that fortunately, because you have such an intimate relationship with faculty while you're doing the program and the staff, I guess, behind classes in both schools in engineering, for data science, and in spatial sciences, and pick the ones that you enjoy, you know? So I think I wouldn't worry too much about maybe if you see a proposed class, a proposed course plan that, oh, I have to do those things, because it can be flexible. But that being said, like Dr. Wilson mentioned, the spatial data science degree is it's going to be half spatial sciences, you know, regardless. So you have to think about whether that half is something that you value, because it can be customized, but it's still, you know, the core and the heart and soul of this program specifically.
So such great suggestion. Thank you so much. And Carol just added that I don't have the GIS background. Would I?
Yes.
That's great. Thank you so much. So Carol, maybe you're ready to submit the application, right? Okay, Jack. Hi, Professor. Thank you for sharing. You just mentioned that spatial data science could be applied to many areas, such as public health. So would you please kindly share more about how spatial data science helps in pandemic time?
In epidemics? Okay.
Yeah,
yeah, so I hope you can see it in China, but just in the last 2 years, I think whatever map was the most viewed map in the world has fallen now to second place, because I would bet my life on the fact that the COVID-19 website is now the most watched map ever produced on the planet. In some senses, the pandemic continues in North America because of the Delta variant. I think, you know, all around the world this is the case, but it's worse and better different places. But you know, when the people from Johns Hopkins bragged that the COVID-19 website, and you know, basically the construction of the website, the streaming of the data, and the updating of the data to the website is using a lot of spatial data science skills, right? You know, some graduate students at the university came up with the idea of a web map that's the center of the dashboard. But then they had help from the private sector to build a whole army of people to do that, because you want to be able to stand and use that site 24/7 for any number of years. And you see the same data science, spatial data science skills being used in any part of the planet where they're trying to use contact tracing in order to help stymie the spread of the virus. So I know that's happening in New Zealand and Australia, happens in the University of Southern California, because we're now back open for in-person instruction. Have used it, given the good job that you've done in order to bring the epidemic under control and to manage and prevent its reoccurrence.
Thank you so much. So Harrison, do you have anything you want to add?
No, I think that, yeah, John covered it.
Thank you so much. So you can find all information that you need in data. I have some questions in terms of the MS program in spatial data science. I just wonder, how many students do you plan to admit every year? So, Professor, please.
I don't think we have an upper limit. So you know, the program I think is only 3 or 4 years old. We've built a very strong partnership with our colleagues in the Department of Computer Science and the Viterbi School of Engineering, and we are both primed to substantially grow the program in the next 2 to 3 years. So part of our motivation for doing a webinar like this is to whether we can't recruit some more ambitious, clever, smart young men and women to come join us.
Thank you so much. That's great. And
Yes.
yeah, absolutely. Yes. Thank you so much. And the next question from Jenny. I'm curious about what's the difference between spatial data science and geographic information science and technology.
So in our case, those 4 master's programs I showed you the title of, they, to some extent, they mix and match different combinations of the same classes. But I think in every case, they have 1 or 2 classes that are unique to that particular program. And so basically, you know, Harrison is an excellent example of a young man or woman that because in the diagram he had with all the words and the different icons for different software products and software skills and so forth. The top half of his diagram is largely the training he got in computer science. And the bottom half was the training he got in spatial sciences. And in the GIS and T master's degree, only a little bit of the top of that slide would have been down at the bottom. Now, you know, I can go back there, I think. Right, so this is the slide I'm talking about. So there are great careers no matter which of those 2 options you pick, but they would lead to different outcomes. And I would think over time, given you know, the Internet of Things and other big data initiatives, that the world is going to move towards the MS and spatial data science and possibly begin to move away from the MS and geographic information science and technology. That's not going to happen. I can see that happening. You know, I produced my PhD with nothing but a mainframe computer that I had to get permission every time I wanted to use it. Graduation, I saw this thing called GIS. In particular, product. And there are things about it that I thought were clunky. Even though I, you know, a personal computer, I didn't have one, hadn't seen one. There's no such thing as a smartphone, a tablet, or anything else. So, you know, these sometimes in life we've got to go where we think the world's going to go, so we arrive there at the right time. And that's certainly true of my career, and I would bet money it's going to be true of Harrison's career as well. You know, the best days for spatial data science are still 5 or 10, maybe 15 years in the future, but the early adopter is going to be the person that arrives there right in the middle of their career, and they then will have a short track to leadership positions and the ability to guide and influence what happens in the next chapter.
That's great. Thank you so much for your answer. So I just noticed that Professor Kamei also helped to answer the question about the STEM program. Thank you so much, Professor. And the next question is from Qi-Wen. Hi, Professor. I studied finance and statistics and looking for a major about data related to solving some business issues. Can I have the chance for this major if my GPA is around 3.0 and I have a GRE over 315? Also, I asked the same question that my schoolmate's data science major. GPA is 3.1. Thank you so much. Professor, do you mind to have answered this question?
John, would you like me to help with that one?
Yep.
So thank you for the question. We look at all aspects of each application very carefully. In addition to the GPA and the GRE scores, we also look at the kind of courses that each applicant has taken on their course transcripts and where they got the kind of grades that they did that went into that overall GPA. We also look at their resume and the personal statement. We'd love to see the kind of evidence of either hobbies or interests, extracurricular activity, summer jobs or research opportunities that you've had that help show your interest and the background that you might have in any of these related areas, and what you see as the value of the opportunity programs. So we look at all of those factors. It's not just, we might have an individual in our program that has a lower GPA and a lower GRE score than a classmate, but has very relevant and on point extracurricular and work experiences. It could be the other way around. So the GRE or GPA score is quote unquote good enough because we really look at the whole application.
Thank you so much. Thank you so much, Professor. So Jivan, if you don't mind, please, maybe you can leave your contact information so that we can follow up on your application. Okay. Thank you so much. So the next question is about Li Shu. It seems that graduates of this major are so high class that they go to government department, NGO institute, or large company to solve major problems. So is there a future for startups or self-employment?
Oh, for sure. Yes. Yeah. There's a world of opportunities and problems that are waiting for smart young men and women, graduates, to wrap their head around and solve. So an example would be that we have global warming. The likely culprits are carbon dioxide and methane that's accumulating and continuously increasing in the atmosphere. And so we need to be able to build business models and systems and learn how to incentivize people to reduce those emissions of carbon dioxide and methane. And that entails, at least in the carbon dioxide case, that we need to sequester the carbon and keep it out of the atmosphere, right? So now, I think that's essentially a spatial problem. And so one of the ways you could do that is to reimagine how we produce food all around the world and try to discover whether there would be a way to pay farmers to grow food in a way that feeds the world's people, but at the same time minimizes the carbon emissions to the atmosphere. There are young men and women and startup companies that have just turned their attention to that now, I bet, in China, in Colombia, in South America, in the United States, but none of them have worked out sort of the financial model nor the kind of data model that would allow for prediction, for verification, all the things you'd need to make that a viable and valuable part of an economic system. But that's just one example. If we turn to Harrison, he might have some examples like that in the oceans.
Yeah, no, I think in addition to the kind of large problems that need tackling by people who are either doing that work independently or in smaller startup spaces, I grabbed the piece of paper that I have here of the jobs that I've been applying to because I'm graduating this spring, and at the moment the majority of them are startups, and there's just so much opportunity, as John said, to apply your skill set in smaller team spaces and also at startups, kind of in tech and otherwise. And then also, in addition to that, I think, what was the other part? Working independently. I know I have one friend who I think was doing some consulting work freelance as themselves as an individual. And then also I'm about to start working as a contractor for a few months with a company out of the Czech Republic to help them build their online weather platform and stuff. And so I think if you take the opportunities in front of you to connect with people and constantly keep networking, you can certainly find opportunities at startups or individual work that fits your niche interests and isn't necessarily that sort of larger scale, like you said, organizational, nonprofit space.
So one thing that USC as a university and the kind of students that come to USC, I think is a big characteristic is entrepreneurship. And so the sky, we really believe that the sky is the limit for any student to pursue their interests. And it's really, there's no limit to the opportunities. It's just a function of each individual having the initiative and the imagination and the passion to pursue them. And so I think our most successful students are the ones that continually think about how they can take advantage of the opportunities and mix them together, knit them together to reflect their interest and goals.
Thank you so much. That's so wonderful. Thank you so much. So come to USC, then your dream will come true. Thank you so much. So the next question is, hello, Professor. First of all, thank you so much for the value sharing. I currently study at NYU, double major in economics and applied math. I was wondering if I apply to MS program in spatial data science after I graduate. So how this program helped me to achieve my career goal to be a business analytics in consulting firm or venture capital company. Thank you so much.
Well, I think in this case, the person probably in the context of our programs would be maybe looking closely at the MS in spatial economics and data analysis and the MS in spatial data science. So the difference would be that in the MS in spatial economics and data analysis, you're going to get some additional breadth and depth in how one uses econometrics to make inferences about how the world works and how they turn those inferences into actionable information that, among other things, would create a set of economic opportunities, either in business or around business and how people are connected to the environment. In spatial data science, you might take a path using your existing training to get to that place. And if you combine your existing training in economics with the spatial data science degree, then you would arrive as a candidate that knew quite a bit about economics and a candidate that knew about really current and up-to-date ways to wrangle really big data, put them together in workflows and produce inferences with those. It would partly be a target of maybe which kind of business you wanted to be in. In the health sciences, the amount of data that affects the business performance is enormous. Even in retail, if you start from the beginning of the supply chain to when the product, there's a big expansion underway. Some time typically is actionable information.
That's so good to know about it. Thank you so much, Professor. So the next question, I have a question for Harrison. So hi, Harrison, which one is your favorite class and why?
Sure. Best of my ability. Yeah. So I think for me, it's tough because all the classes I find really interesting. I'm like one of the anomalies and a few people who started in undergrad kind of knowing. I came in pre-med thinking that I wanted to do the surgeon thing and then quickly pivoted to geography because I realized that I was more interested in the large scale stuff. So now that my interest has been, I guess, cultivated by years, like all the classes I'm in because they're tailored to what I'm interested in. That being said, I do like pushing myself and doing things that I guess committing to something I don't know that's really great machine learning. And so I took the machine learning class. That was the first data science like Viterbi class that I took as part of this degree. And it had a prereq in another class, and it required a lot of kind of getting. I ended up doing well in the class and thoroughly enjoyed that course in particular, because the professor provided a rather robust overview. It was, I guess, really validating to know that I had achieved it at the end, and then also along the way, it whipped me into shape and really showed me the power of a lot of these kind of techniques that we talk about in abstract, and how to apply them. So, ML.
Thank you. I just noticed that Professor Kamei have also helped to answer previous two questions. Thank you so much, Professor. And so
sure. I think I've like already for like the kind of goals that I have, but I think better at Python, learning different machine learning libraries, understanding some of the data science buzzwords like distributed file systems or data mining, parallel processing, and understanding all those technologies, whether it's Hadoop, Spark, running things on AWS EC2 instances, or understanding S3 buckets and how to interface, data across different platforms. Again, I, coming from the geography background, and further reinforcing that through classes, I'm thoroughly interested in kind of the data science side of things. That in interviews, and also kind of sift through job applications and figure out what works for me. And then in addition to that, just continually adding on to my remote sensing toolkit and spatial and analytics toolkit has been incredibly helpful. Degree of confidence, especially in areas like Dr. Wilson said that are still kind of in development and continuing to flourish, right? It's cool to be someone who feels as though they have a good understanding of not only my own spatial technologies and how it's moving forward.
I noticed that Vicky just said, I really appreciate. Thank you, Dr. John, Dr. Wilson. Thank you, Dr. Kamei. I will carefully consider the MS program in spatial economics and data analysis program. Thank you so much. And our next question from Rui Zhi. Thank you so much for sharing. I'm very interested in spatial data science program, but I would like to ask how difficult it is for a non-GIS background student to learn this major. Do I need to take many courses related to geography, Professor?
I don't think so. So, I think about, well, I don't know whether it's exactly half, but quite a large number of students come to the spatial data science program and perhaps the information technology. And so, they have very little knowledge or understanding of not just geography, but most of the social sciences, and for that matter, probably the natural sciences. They're probably well versed in GIS and perhaps remote sensing, but they have not very much formal training in computer science. Myself as an example of that. I think the path might be, different parts of the degree might be past training as well as their aptitude and their interests. But I don't think any part of it's beyond reach. I think, I think Harrison is quite inspirational story about machine learning was of that character. They're done and they graduate and they could look back and say they were never tested, then they've really probably wasted a couple of years of their life. And whereas if a person found something that was both interesting and various parts of it was a test, then they could have the confidence that they are going to leave the program a better person than when they started. And hopefully that's going to translate to better opportunities in life and a better career and better life, etc., etc. So I think that want to put. We brought Harrison along to show you that that's easily possible.
I think it's also easy, maybe from the student perspective, especially y'all, thinking of applying, to hear that from the directors of the program and think, oh, it might just be like advertising, or oh, it's just like an ideal. And no, you really do feel, I guess, appreciated, and the attention that our department and this program has to building up students from diverse backgrounds and helping them reach those successes that Dr. Wilson just outlined is really something that is tangible in this environment, and I'm very thankful for it.
Thank you so much. Thank you so much. I think it's pretty much the time to come to the end. Thank you so much today for Professor Wilson, Professor Kamei, and our wonderful master student Harrison. So right before the end of the webinar today, so to our two great professors and Harrison, any tips you or anyone want to give?
Well, my advice is always the same: chase your dreams.
Thank you so much.
You kind of broke up there. Is it one piece of advice? Is that the
chase your dreams.
Okay.
That was John's advice.
Do we have to each provide one? I'm sorry, it like glitched out and I missed the.
I think
it was.
Oh no.
It was just as closing.
Oh, that's the close. Oh, sorry, I goofed it.
No.
Okay, thank you so much. Thank you so much. And thank you all of our audience today. Thank you for tuning in, and we truly appreciate you joining us today.